Alrighty then, right, I've turned the cylinder for this Triskelion sphere. It's in two halves, which I'll show you in a minute. I did each half by first using this acrylic chalk, double siding tape the square piece of wood onto it, centered, and turning a mortise into one end, into the other end, and then flipping it onto the normal chalk on that mortise and turning a tenon. So each piece has got a tenon on one end and a mortise on the other. And I checked first that the sphere goes into that mortise right to the edge of it, and I made sure that I'd got enough depth there that that mortise, that tenon, sorry, isn't interfering with the sphere, which it isn't, which you'll see in a minute. So I've drawn a line across, and this is how I'm working now with my sphere turning. So you can see it comes in half, and there's a little jam tenon, if you like. I turned a tenon that jammed into one side and then fitted the other side to it, a little bit loose, so I'll put a bit of tissue in there, and I'm using a cup centre to just hold it closed when I turn it. Now, this is how I get my measurements. A little bit busy, hold on, I need to just fetch something. And I'll take that out the chalk so we can see. Oh, I hate these record power chalks. I don't, but I do. Right, can we see? Yeah. Oh, I need something else, hold on. So this new set of calipers, Starrett's, I took, they're chisel tipped, very sharp. So I took the, measured the diameter using that, drew a line on a piece of paper, pressed it in on the line either end to get the diameter of the circle. Then used a compass firstly to bisect that line to find the centre, and drew the circle. I need to move my tailstock back a bit, I haven't quite got enough space there. Okay, so that's an exact size circle for that. Well, it's got the centre, and I've got those 4 points. So setting it at the radius, I can then find these points, top and bottom, to put a square around that circle, and also drawing the diagonals for an inscribed square at 90 degrees or 45 degrees, isn't it, to that circle. Right, now if I set my compass to that diagonal and draw to there and do that from the other side, that's my octagon. To turn my cylinder into an octagon, that's the lines that I'll need. But I haven't done that, I've done it from the centres. It's only to show the octagon, it doesn't need to do this. And from there into there, and I've done that all the way around so that you can see the octagon. So that's how I get my octagon measurement, and then I can use that when I put that back together to transfer that measurement from the centre line out, and then I can use I can also use it to go down the side. I can use the overall measurement. So I'll do that now. Anyway, that I've also divided this into 6, which I'll come back to when we're doing the dodecahedron, because everything that I need is in this diagram. And bear with me again, sorry. Now, I don't need to do this diagram every time now, because I'm making sure that as I do this, that these points are on my scale. So instead of constructing this is what your scale is saving you having to do. You just set the radius on 6 divisions, and then you can just use your compass to read off whatever measurement you need. So let's put this back in the chalk. Now, where did I put my chalk key? There. I'd been down a bit of a rabbit hole trying to work out how to get this accurately transferred between this and paper so that I could do the geometry, and it turned out that all I needed was a good sharp set of you couldn't use them turning, because that sharp head can catch and you'd be in a world of hurt. So let's put that together back with the line lined up, get that out of the way, and literally no rulers, no measurements. I've just used a straight edge, a compass and a pencil, and those dividers. That's the only things used in doing this. So now I can transfer onto that line marks for the octagon, so I'll also mark those down the side. I can't reach in that side, so I'll have to do one side, then flip it round and do the other side, and then same to 16, and then for the sphere after that is easy. So I'll get this turned out to a sphere. Oh yeah, that's the other thing, sorry. The tenon is really around that part there, so I know that it doesn't go into my sphere, so that I can just turn round to the tenon, turn it spherical round to the tenon on each side, and then I'll either deal with the tenon when it's between cups, when it's hollowed and glued together, because obviously to hollow this is easy. You just flip it back round. Well, you just take one half off and hollow it. Hollow it by chasing. Once you've got this sphere, you're just going to chase that 6 mm. Well, I'm going to go for a 5mm wall thickness. I'll just chase the wall thickness rather than. I probably will make a template as well, but that'll be just to check it out at the end. I'll just chase that 5mm wall thickness all the way in, and then I'll have the hollow sphere which I can glue together. It's bowl orientation, so that I'm gluing on side grain, so it should be nice and strong. And then once it's glued together, I can turn off the tenons into the sphere. So that's the plan. I'll go ahead and do that. Thanks for watching.